Welcome back, viewers. Today I want us to look at some past Kcse questions that were tested to the candidates previously and see how these questions are normally framed and see what is expected of you when answering such questions. So that is the reason why I've decided to take you back to previous questions, not with an aim that they may be repeated word for word, but for you to know the expectation of the examiner during that particular time in testing. So in question 1, a quadrilateral ABCD has vertices A 4, -4, B 2, -4, C 6, -6, and D 4, -2. On the grid provided, draw the quadrilateral ABCD. 1 mark. 1, B1, C1, D1 is the image of ABCD and a positive quarter turn about the origin. On the same grid, draw the image A1, B1, C1, D1. A2, B2, C2, D2 is the image of A1, B1, C1, D1 and a transformation given by the matrix 1, 0, -2, 0. 1. Determine the coordinates of A2, B2, C2, D2, 2 marks. On the same grid, draw the quadrilateral A2, B2, C2, D2. And then finally, determine a single matrix that maps ABCD onto A2, B2, C2, D2, 2 marks. So in total, such a question would earn you 10 marks in section B. Now, using the grid that is required, you're going to take a graph paper, get a graph paper, of course in the exam the grid will be provided to you. So this is the x-axis. So we can label 0, 1, 2, 3, 4, 5, 6, -1, to -6. On the x-axis again, we can label from -1 -6. On the y-axis, can label up to 7. Of course, that continues. So this is the y-axis. This is the x-axis. Therefore, we can now plot the points. The point A is 4, negative 4. A is 4, negative 4. Put a mark here. B is 2, negative 4. B is 2, negative 4. Put a mark here. C is 6, negative 6. 6, negative 6. Put a mark here at the bottom. And D is 4, negative 2. Now using your ruler, join those points according to the trend that was given, A to B, B to C, and finally C to D, and D to A to complete your figure. So that is point D. Point D is here. So we have now the object point A, B, C, D. In part B, we are told to find the image A1, B1, C1, D1 of ABCD and a positive quarter turn about the origin. On the same grid, draw the image A1, B1, C1, D1. Now, that one can be done using two ways. You can either construct angles through the origin at 90 degrees and then you rotate every point through 90 degrees anti-clockwise, because positive 90 degrees or a quarter turn means positive 90 degrees and anti-clockwise. Or second, we can still get the matrix of transformation. It's easy for us to get the matrix of transformation. So positive quarter turn means positive 90 degrees. This means anti-clockwise. So we want to rotate our object through 90 degrees anti-clockwise, and the point will be through the origin. So to get our matrix of transformation, we are going to use the points I and J of the unit square. So if you have the Cartesian plane, that is the y-axis, this is the x-axis, the point I is normally given by the coordinate 1, 0. And the point J is normally given by the coordinate 0, 1. So to get the image point I1, we rotate I1 through 90 degrees anti-clockwise. So if this is our point there where we have I, and this is our point where we have J, this is J is 0, 1, and I is 1, 0. So we rotate I through 90 degrees anti-clockwise, it will map onto point J. So the new image point of I1 will be 0, 1, like that. And if we rotate J through 90 degrees anti-clockwise, it's going to map onto a new point J1, which will be negative 1, 0. Negative 1, 0. So J1 will be equal to negative 1, 0. So to get our matrix of transformation, let us call it M. M now will be given by 0, 1, negative 1, 0. So that is our matrix, 0, 1, negative 1, 0. Now we use that matrix to get the image point A1, B1, C1, D1. So we take the matrix M, 0, 1, negative 1, 0, multiplied by the point A, B, C, D, to give us the image point A1, B1, C1, D1. So when we multiply this, the point A, 4, negative 4, B, 2, negative 4, C, 6, negative 6, and D, 4, negative 2, like that. So we'll go row, column, row, column, row, column. So we start with row 1. So, of course, these two matrices are compatible, so they can be multiplied together. This is order 2 by 2, and then this is also order 2 by 4. So they are compatible in that the number of columns in the first matrix is equal to the number of rows in the second matrix. Now when we multiply this, we get 0 times 4, 0, negative 1 times negative 4, 4 plus 0 gives you 4, 0 times 2, 0, negative 1 times 4, that gives you 4, 4 plus 0, that gives you 4, and then 0 times 6, 0, negative 1 times negative 6, 6, 6 plus 0, that gives you 6, 0 times 4, 0, negative 1 times negative 2, 2, so 2 plus 0 gives you 2. In the second row, 4 times 1 gives you 4, 0 times negative 4 is 0, so 4 plus 0 gives you 4, 1 times 2 gives you 2, 0 times negative 4, 0, 0 plus 2, that is 2, 1 times 6 gives you 6, 0 times negative 6, 0, so 0 plus 6, that is 6, and 1 times 4 gives you 4, 0 times negative 2 is 0, so 0 plus 4, that gives you 4. So we now have the coordinates A1, B1, C1, D1, and we are told, after getting that, on the grid provided, or on the same grid, draw A1, B1, C1, D1. So we now come to our grid and we draw the points that we require. A1 is 4, 4. A1 is 4, 4. So this is 4, 4 up here, put a mark. that is A1. B1 is 4, 2. This is B1. C1 is 6, 6 up here. C1, and the D1 is 2, 4. D1. Again, take your ruler, join A1 to B1. B1 to C1. C1 to D1. And finally D1 to A1. So you now have the object point and the image point. We have the object point and the image point. So this is a rotation of positive 90 degrees through the origin. So A has been rotated to A1 through positive 90. So through an angle of 90 degrees anti-clockwise. In the next question, we are told that A2, B2, C2, D2 is the image of AB, A1, B1, C1, D1 under transformation given by the matrix 1, 0, negative 2, 1. So let us get this matrix. We call it now matrix N. N is given by 1, 0, negative 2, 1. And in part 1, we are told to determine the coordinates of A2, B2, C2, D2. So we're going to take matrix N multiplied by A1, B1, C1, D1. So this means we take 1, 0, negative 2, 1 multiplied by the points A1, B1, C1, D1, 4, 4, 4, 2, 6, 6, 2, 4 to give us the new points A2, B2, C2, D2, like that. Again, when we multiply this, we're going to get 1 times 4, that is 4, 4 plus negative 8. This gives you negative 4. 1 times 4 is 4. 4 plus negative 4, 0. 1 times 6 is 6. 6 plus negative 12, negative 6. And 1 times 2 is 2. 2 plus negative 8, negative 6. And again, the second row, 0 times 4 is 0. 1 times 4 is 4. 4 plus 0 is 4. 0 times 4 is 4. 1 times 2, 0 times 4 is 0. 1 times 2 is 2. 2 plus 0 gives you 2. 0 times 6 is 0, 1 times 6 is 6, 6 plus 0 gives you 6, and 0 times 2 is 0, 1 times 4 is 4, 4 plus 0 gives you 4. So we have the points A2, B2, C2, D2. In the next question, you're told on the same grid, draw the quadrilateral A2, B2, C2, D2. Now that we have the points, we come back to our grid or our graph paper. A2 is negative 4, 4. Negative 4, 4. Put a mark here. That is A2. B2 is 0, 2. 0, 2. Put a mark here. That is B2. C2 is negative 6, 6. C2 is negative 6, 6. Put a mark up there. And then D2 is negative 6, 4. D2 is negative 6, 4. So negative 6, 4. Put a mark here for D2. Again, we join these points. E2 to B2. B2 to C2. B2 to C2. C2 to D2. And D2 to A2. Like that. So we have the three figures as required. Finally, you're told to determine a single matrix that maps ABCD onto A2, B2, C2, D2. Now, to get that single matrix of transformation, the single matrix now, we're going to take, we have got two matrices. One of them is M and the other one is N. So we're going to take the first matrix onto the right, which is matrix M, that is 0, 1, negative 1, 0, pre-multiplied by the last matrix of transformation, which is 1, 0, negative 2, 1. So why do that? Because under transformation, so when you multiply these two matrices, you're going to get negative 2 in the first row, that is 1 times 0, 0, negative 2 times 1, negative 2 plus 0, negative 2, 1 times negative 1, negative 1 plus 0, negative 1, 0 times 0, 0, 1 times 1, 1, 1 plus 0 gives you 1, and 0 times negative 1, 0, and 1 times 0, that gives you 0 again. So the final matrix will be given by negative 2, 1, negative 1, 0. So thank you.